Beyond Earth lies a universe of volcanic wonders that make Mount Everest look tiny. From Mars's towering Olympus Mons to Jupiter's constantly erupting moon Io, these space volcanoes tell incredible stories of our cosmic neighborhood's raw power. Let's zoom in on Mars's crown jewel, Olympus Mons. This massive volcano is truly in a league of its own, standing 3 times taller than Mount Everest at a whopping 21.9 kilometers high. But what really sets it apart is its incredible width. It's about the size of Arizona. The gentle slope of Olympus Mons might surprise you. If you were walking up it, you'd barely notice you're climbing a volcano. This gradual incline exists because Mars has lower gravity than Earth, allowing lava to spread out far and wide before cooling. The volcano's base features a dramatic cliff that drops 6 kilometers straight down, created by ancient lava flows. Scientists think Olympus Mons could still be dormant rather than extinct, potentially holding secrets about Mars's inner workings. Let's travel to Jupiter's moon Io, the most volcanic place in our solar system. While Earth has around 40 active volcanoes, Io puts on a much bigger show with over 400 constantly erupting volcanoes. These aren't your typical Earth volcanoes. They shoot sulfur plumes up to 500 kilometers into space. The reason for all this activity? Jupiter's powerful gravity pulls and squeezes Io like a stress ball, heating up its insides until they burst out through the surface. Io's surface looks like a cosmic pizza, painted in yellows and reds from all the sulfur and silicate materials. The heat and activity are so intense that Io's surface gets completely redone every million years or so. That's super fast in geological time. Some of Io's volcanoes create lava lakes that span hundreds of kilometers, making them visible even from Earth with powerful telescopes. Now let's explore something completely different. Ice volcanoes. Saturn's moon, Enceladus, has massive geysers that shoot not lava, but ice and water vapor into space. These cryovolcanoes blast ice particles up to 50 miles high through cracks in the moon's frozen surface. This creates a stunning display that feeds Saturn's E-ring. But what powers these icy fountains? Deep beneath Enceladus's frozen shell lies a hidden ocean, heated by Saturn's gravitational forces. The pressure builds until it finds escape routes through the surface cracks, creating these spectacular ice geysers. Scientists have even flown spacecraft through these plumes and found organic molecules, making Enceladus one of the most promising places to look for life beyond Earth. Moving to the outer edges of our solar system, we find Neptune's largest moon Triton, where volcanoes work in reverse. Instead of hot lava, Triton has nitrogen geysers that erupt in 390-degree temperatures. The sun heats up a thin layer of nitrogen ice just enough to turn it into gas, building pressure until it bursts through the surface like a cosmic champagne bottle. These eruptions shoot dark nitrogen gas and ice particles 5 miles high, creating dark streaks on Triton's surface as materials fall back down. When Voyager 2 flew past in 1989, it caught 8 of these dark plumes in action, looking like giant black smokestacks against Triton's icy surface. The frozen nitrogen on Triton acts much like dry ice does on Earth, turning straight from solid to gas. Venus is a planet shaped by massive volcanic activity, with about 80% of its surface covered in solidified lava flows. These vast volcanic plains tell the story of huge eruptions that would make Earth's biggest volcanic events look small in comparison. The intense heat and pressure on Venus caused lava to spread out smoothly across the surface, creating massive fields of hardened volcanic rock that stretch for hundreds of miles. Scientists have spotted over 1,600 major volcanoes on Venus, though they suspect there are many more hiding under the planet's thick clouds. Unlike Earth's relatively recent volcanic history, most of Venus's mega eruptions happened between 300 and 600 million years ago. The planet's surface temperature of 900 degrees C keeps the rock so hot that any signs of ancient volcanic activity are remarkably well preserved. Let's visit Ceres, the largest object in the asteroid belt, where we find a mountain unlike anything on Earth, Olympus Mons. This strange peak rises about 3 miles high and looks like someone dropped a giant scoop of ice cream on Ceres' surface. But it's actually a cryovolcano, made mostly of ice mixed with bits of rock and salt. Unlike regular volcanoes that spew hot lava, Olympus Mons once oozed a cold, slushy mix of water, mud, and other frozen materials. Scientists think it formed when underground water and minerals pushed up through cracks in Ceres' surface, creating this dome-shaped mountain. What makes it even more special is that it's relatively young, probably less than 200 million years old, suggesting Ceres might still be geologically active today. Let's explore one of the most exciting mysteries in our solar system, the hidden world beneath Europa's icy shell. This moon of Jupiter has a thick ice crust, but scientists think there's some serious volcanic action happening deep in its ocean floor. Unlike regular volcanoes, these underwater ones might look more like the hot vents we find in Earth's oceans. The heat from these possible volcanoes could be creating warm spots in Europa's vast ocean, making it one of the best places to look for alien life. Recent studies suggest that the ocean floor of Europa might be as active as Earth's, with hot spots releasing minerals and heat into the water. These underwater volcanoes could work like giant hot water heaters, keeping parts of Europa's ocean warm despite being so far from the sun. Mercury might look like a quiet, cratered world today, but its past tells a different story. Early in Mercury's life, massive volcanic eruptions shaped huge parts of its surface. These ancient lava flows filled up giant impact basins, creating smooth plains that cover about 27% of the planet. The largest volcanic area, the northern volcanic plains, is about the size of Texas. Unlike Earth's volcanoes, Mercury's volcanoes were more like huge cracks that let lava flood out across the surface. The planet's strong gravity made the lava spread out in thin sheets instead of building up into mountains. Scientists found proof of this volcanic past in 2008, when they spotted unusual bright spots on Mercury's surface. These turned out to be volcanic vents where lava once burst through. Saturn's moon Triton has a fascinating feature: lakes filled with liquid methane instead of water. These lakes might have an unexpected source: ice volcanoes deep below the surface. When these cryovolcanoes erupt, they release methane from Titan's interior, which then rains down and fills the moon's lakes and seas. The largest methane sea, called Kraken Mare, is bigger than Lake Superior. The process works like a weird version of Earth's water cycle. Methane evaporates, forms clouds, and rains back down in a steady cycle. Recent space missions have spotted what look like ice volcano peaks on Titan's surface, suggesting they might still be active today. This could explain why Titan's methane lakes don't disappear, even though sunlight should break the methane down over time. As we plan missions to other worlds, space volcanoes pose real challenges we need to tackle. On Mars, dust from ancient volcanic regions could damage spacecraft equipment and clog air filters in future bases. Io's constant eruptions create radiation hazards that could harm both astronauts and equipment. Any mission there would need serious shielding. Even seemingly quiet places like Europa require careful planning, since hidden warm spots could make the ice dangerously thin in some areas. The good news? Scientists are already working on solutions, from special protective materials to detailed mapping systems that can spot dangerous zones. Understanding these volcanic risks isn't just about safety, it's key to picking the best spots for future bases and research stations. Thanks for joining our journey through space's most incredible volcanoes. Each one tells an amazing story about our solar system's power and beauty. If you enjoyed learning about these cosmic wonders, hit like, subscribe, and share with fellow space enthusiasts.